So number one says two vertices for a right triangle are -4, 3. So that's obviously right there. And 4, 5. So that is obviously right there. Which is the possible third vertex? A.
B. Definitely.
A is -3, 1. Okay, so that would be right there. What is the slope between those 2 points? Down 2 over 1. So that slope is -2. What's the slope between these 2 points? Up 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7. So it is not 1/2. Close. But it looks, okay, hold on. It looks right, so it's a good guess, but it's wrong, and we know that because what's true about the slopes of perpendicular lines? They have to be opposite reciprocals of each other, and these ones are not. So that is not going to work. So what did somebody else want us to try? D. B. B is in the, is in, oh, 0, 0. Okay, so the slope from here to here is down 1, 2, 3 over 1, 2, 3, 4. So that's -3/4. The slope from here to here is up 1, 2, 3, 4, 5 over 1, 2, 3, 4. So that is 5/4. So that doesn't work either. What? Try D. You want to try D? 4, 0. Yeah, I don't really like that much at all. Yeah, that was bad. 1, -3.
Are you saying, wait, is 4, 0 not it?
4, 0 didn't, no, because that has a, yeah. We got nothing there. So C is at 1, -3. So where would the right triangle be there? I mean, which angle?
It's nowhere.
Wow, it's no good either. So none of them work?
Yeah.
Did I do something wrong?
She's so angry.
It's -4, 3. Okay, so the answer to number 1 is false. The key is that you would know that they need to be opposite reciprocals of each other, so you're not just going to look at it and guess.
Wait, so what is it?
False.
Alright. So
No solution. Okay, so then the next one, let's try this. -4, -2. -1, 6. And 2, -2. So let's draw it first. What kind of a triangle do you think that is? It appears to be isosceles. And the way that you know that for sure is to get from this point to this one, I have to go up 8 and over 3. And to get from this point to this point, I have to go down 8 and over 3. So that means these two sides are going to be congruent, and so it is an isosceles triangle, which is steep. All right, now we're going quadrilaterals. Get rid of you. Now we're going quadrilaterals. So we've got -2, 5. Okay, so there are the points. Once again, good idea to connect the points because then that gives you a better idea of what you're kind of shooting for. What might you guess? Rhombus? What would have to be true if it was a rhombus? All sides have to be equal length. So up, this would be up 8 over 3. This would be up 3 over 8. This is down 8 over 3, and this is down 3 over 8, and so that does in fact work out. So that one is a rhombus. Opposite sides are parallel and congruent. So that is B. Okay, then come on now. Next one. We have two vertices of a rectangle. One of them is at 4, 3, and one of them is at 2, -1. What are the possible coordinates of J and K? Anybody want to try a guess on that one? What? D. Did you say E?
D.
Oh, D. Okay. 0, 0, and 2, 4. Yeah, that's going to work out because this is down 1 over 2, down 1 over 2, so those are parallel. This is up 4 over 2, up 4 over 2, so those are also parallel and congruent. And then this has a slope of 2, these two have a slope of -1/2. So that will work out. So it is B. Okay.
Wait.
It's D, not B. Don't listen to him, he doesn't know what he's talking about. Clearly. Okay, and then this one we start with the shape. All right, and they tell us that this is a parallelogram, and we're supposed to verify that the diagonals of a parallelogram bisect each other. So what does that mean? I have to show. Not that they're perpendicular, that's only in a rhombus. What? They have the same center, same midpoint right here, okay? So to show that it's halfway between here, how do you want to do that? Don't have a ruler. Yeah, I can do the slope thing again. So to get from here to here is up 1, 2, 3, 4, 5 over 1, 2, 3, 4. And from here to here is up 1, 2, 3, 4, 5 over 1, 2, 3, 4. And so since those are the hypotenuses of congruent right triangles, they're the same. Same thing here, down 1, 2, 3 over 1, 2, 3, 4, 5, 6. Down 1, 2, 3 over 1, 2, 3, 4, 5, 6. Okay, so somehow you would just need to show that that's true. All right, next section, number 1. To determine the volume of a traffic cone, its radius must be measured. What unit corresponds to the radius of a traffic cone?
Inch.
Inches, yes. Cubic feet is obviously volume. Square centimeter is area. And grams are mass. Okay, number 2. The U.S. Census Bureau reported a national population of 299 million, blah, 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 on its population clock in mid-October, da, da, da. One can say that the U.S. population is 300 million and be precise to 1 digit. Although the population had surpassed 300 million by the end of that month, explain why 3 times 10 to the 8th remains precise to 1 digit. Okay, so what they're saying is, if you go 299,894,924, you can approximate that as 3 times 10 to the 8th, right? And then they said by the end of the month it's more than that. Maybe it's this. I'm just making that up, yeah. But even though it's more than that, why would you still be able to say that the population is, right, because you're rounding to the nearest, what?
100 million?
100 million, right. So it would still be true if you round to the nearest 100 million.
Would be true.
Okay. Next section. This is something that we spent a lot of time on, but you struggled with it. 1 centimeter equals 10 millimeters. How many square millimeters are in 15 square centimeters? How'd you get that?
C.
How many square millimeters are in 1 square centimeter if there's 10 millimeters in 1 centimeter? See, not 10, 100, because you are making a square. Yeah, because it's a square centimeter. And in this square, there are 10 millimeters on this side and 10 millimeters on that side. So how many millimeters are there in the middle? 100. So there's 100 square millimeters in 1 square centimeter. Okay? So if you want to know how many square millimeters are in 15 square centimeters, right, you don't go 10 times 15, you go 100 times 15, which would be 1,500 square millimeters. Okay? I don't know. Something for you to click on maybe? I don't know.
I know, maybe it was just.
All right, so number 2 is the same thing. It says 1 yard equals 3 feet. How many square yards are there in 18 square feet? So you have to ask yourself the same question. If I have a square yard, how many feet is it on each side? 3. If I have 3 feet this way and 3 feet that way, what's my area? 9 square feet. So 1 square yard does not equal 3 feet, it equals 9 square feet. So 18 square feet would be 2 square here yards. Okay? Still struggling with that a little, Alyssa? Okay. Well, how many square feet do I have in there? 9. So if I have 18 square feet, then I must have 2 square yards. Because 18 divided by 9 is 2.
Wait, what number is this?
This number 2 on page 40.
And what's the answer?
2 square yards.
Why did I get D? Oh, no.
Because you said, you went 3 times 18 because there were 3 feet in a yard or something, so you went 3 times 18, but that's totally wrong. I don't know what you're doing. Oh, good, but we only have 2 more left.
Then we're done.
Yep. Then we're done. We all have people gone today. All right, a 56 kilobyte computer modem took 4 hours and 9 minutes to download a 100 megabyte, sorry. How big was the file that was downloaded on the same modem? So we don't really care about this part because it's not changing at all. If it only took 54 minutes to download. So what do we have to do to solve this?
I did a proportion.
You did a proportion, good. Way to do it. And what did you use in your proportion?
249.
Where in the world did you get 249? There's no 249.
Oh, I did the hours.
Oh, 4 hours is 240 minutes plus 9 more minutes, so that's 249. Okay, gotcha. Because, okay, 100 megabytes, good.
Equals 54 over X.
Awesome. Okay, does that make sense?
22.
And that comes out to be 22,
D.
which is D. Okay. And finally, the last one. An American tourist arrived in South Korea and went to the airport currency exchange office and exchanged a 100 US dollar bill for 1,125,110 South Korean won. The American then went to lunch and paid 258,775.30 won. How much did the lunch cost in US dollars? So what do you do with that? I don't know what the exchange rate is between the dollar and the won. We can look that up in just a minute though. Oh yeah, they should have. There's caps. That's right.
Dollars and cents not happening in there. Because I was just chapter.
Okay, so Blake says, there's another simple proportion problem. He put the US dollars 100 on top over the South Korean won on the bottom. And then that's going to be X over 258,775.30. So same thing, you cross multiply and you divide. And what do you get? 23 bucks?
Yeah.
I divided, yeah.
You just did what?
I just divided.
But what did you get when you divided?
23.
What was it, a 0.23?
No.
Oh, it wasn't?
I don't know what I did.
Okay, you got it right.
Yeah.
So everybody's happy.
Yeah.
Okay, good deal. All right, make sure your name's on those. And